So, dear students, welcome back to our new article on the surface tension is Jaeger's method for the determination of the surface tension. So, it should be remembered there is a capillary action method. So, when column of the liquid that rises in a tube dipping vertically into liquid is slowly forced down by applying the gas pressure. So pressure is steadily increased to well marked maximum just before the bubble escape from the end of tube. A concept here, the capillary tips, if it is immersed in water or the liquid, then what happens is the capillary action, a liquid is rising inside the tube. So if you have to apply the gas pressure from the upper side, so pressure you have to steadily increase. Then what happens is pressure, due to the pressure, your liquid will be the move in a downward direction. So the air or the gas will be the bubble will be created at the end of the tube, and that bubble will be escape from the tube. So when bubble is formed, so excess pressure inside the air bubble in liquid is a standard formula twice T upon R. So T is the surface tension and R is the radius of that bubble. Now excess pressure can be measured by using the Jaeger's methods which produce the air bubble. Okay. So for that purpose we consider experimental arrangement for the determination of the surface tension. So that experimental arrangement is like this. If you have to see the figure, so you should remember there is one glass tube that is A, B, C, D. So it's one end of the glass tube is connected to the Wills bottle. Okay. So one end of this bottle is fitted with the tube A, B, C, D. Another mark of this bottle is fitted by the funnels. Now this other end of the tube is you have to calibrate it as a capillary tube. That is its diameter will be the 0.2 millimeters to the 0.5 millimeter. So this is a vertical portion which is an acts as a capillary. Okay. So it's the end you have to immerse in water or liquid whose the surface tension you want to determine. That is known as experimental liquid. So here is a manometer tube is connected to the glass tube that is ABCD to measure the pressure. So this is an experimental arrangement for the Jaeger's method for determination of the surface tension. Now the liquid which is filled in a manometer tube having the density is less than the density of the experimental liquid. So there is due to the small pressure there is a greater difference in a manometer's column. So you have to determine the height difference in the liquid when there is a gas air bubble is formed or it is escaped or detached from the tube CD. At that time you have to measure the maximum pressure, that is a height difference in a manometer tube. Okay. So we will consider working of this capillary tube. So working of the capillary tube is a very simple and it is understand. You have to remember once again there is a figure. So if you have to observe this figure, so you should be remember here. Here your capillary tube is immersed in the tube. Then what happens to the capillary action? There is some liquid is inside the tube. It is rise inside the tube. Now you have to consider by using the funnel mass, you have to fill the water through the funnel slowly or steadily. Then what happens when your water is enter in your Wills bottle, then air which is trapped in your Wills bottle, that air same amount of the volume of that water, that air is forced out through the Wolf's water. Then what happens? That air will be moved through these pipes. So here is an pressure. So you have to see here your bubble is forced. So there is an pressure. So it will move your the capillary liquid. So when it is an air forced, it is come to the air. Then when force, you have to increase slowly. You have to feeding water. Then what happens? There is an pressure will be the created, that this pressure means this is a force of the your liquid which is an inside tip is a move in a downward direction. If it is a slow process is continuously, then there is a one stage is there. Your air will be the just come at the end point of the your D. So here is an air bubble is a form that is an hemispherical, and that air bubble at the end of the point D is in form which is an hemispherical, and at a certain pressures it will be the detached, and there is a maximum height difference. So once your bubble is detached, once again you have to fill your water continuously, then there is another air bubble will be the formed at the end point of the D. So you should be remember what happens there. So pressure inside the bubble is a maximum, which is indicated by the height difference in a two column of the manometer. Suppose H is a height difference. Now bubble now becomes unstable when it is grow at the end point of the B. So its a radius of that bubble must be equal to the radius of the your capillary tube. Now this is the initially increases as the pressure inside it is increases due to surface tension. So at the equilibrium condition between the internal and external pressure is destroyed after some time. So therefore bubble will be detached from the tube. So why bubble is detached? Because the equilibrium condition is destroyed. Once your air bubble is destroyed, then you should measure the pressure. Now consider when just before the bubble break away from the point B, that is the point D at point C in our experiment. So at point C your bubble is a break, then pressure inside the it is equal to the pressure at a point D. So pressure here is the same as the pressure here. So pressure at the manometer, that is P1 is equal to P plus H rho G. Now rho is the density of the liquid which is used in a manometer. P is your atmospheric pressure. So H rho is the pressure due to the liquid column in a manometer. So this H rho G is a pressure due to liquid column. P is an atmospheric pressure. So P1 is a pressure here. You have to measure, that is P1. Now when bubble is just break away from the your end point of the D, then pressure on it is equal to that level of the D in a beaker. So pressure at a point D is equal to P2 is equal to P plus HdG. Now H is it is a small h actually. Small h is the depth of the deep inside the liquid. So D is your the density of the liquid, and this is the here is a small h actually. So here is the h. So when bubble you have to just break away from, here is a D. So it is an also D. So it should be remember D, that is the end point of the your capillary tube. So D is the density of the liquid, which is experimental liquid. So we want to determine the surface tension of that liquid. So you should be determine the excess pressure inside the bubble. It is equal to the excess pressure is equal to the pressure difference. So pressure difference is P1 minus P2. So we got this P1 is equal to P plus H rho G and minus PH dG. So we got this equation. PP will cancel, remaining there is G is a common for a second term, it is common. So we got the H rho minus H. Now this is the excess pressure inside the bubble. According to the definition, that is excess pressure inside the bubble standard formula is the twice T upon R. So this excess pressure must be equal to this excess pressure. So you have to equating these two equations. So we got the twice T upon R is equal to H rho minus HD. So you have to writing the equation for the T. So you got the H rho minus HD into GR divided by 2. So it can be by measuring the your H is a high difference in columns. H is the depth of your capillary tube inside the liquid. R is the radius of your capillary tube. If we know, then you have to determine the surface tension of that liquid. So this is an working of your the experimental determination of surface tension by the Jaeger's method. So you should be keep in mind it is a very simple experiment, but they will be asking question for the 4 marks. It's a simple construction and simple working. You should be remember. Now what is an advantage of the Jaeger's method? Actually radius which is measured at a point D, because there is a capillary, we can be always measure the your radius at the edge of the your capillary. So you can measure the radius at the lower end, and the bubble which is formed which is also at the lower end. So there is no error due to the non-uniformity in before the tube. Means if there is a tube is a non-uniform, then there is no any error is introduced in your calculation, because the bubble is actually formed at the lower end. We can be measure where the actually radius of that capillary. Now each and every time fresh bubble is formed, so greatly it reduces the possibility of the error and due to the contamination of the surface. Angular quantity is not required. If you have to observe the formula, this angular quantity is not required. Then we can be also small quantity of liquid is required. It is not required the great value of the your liquid. So this is an advantage. What is the application of this method? Application of this method can be this. It is used to study the variation of the surface tension with the temperature. Means we can be the study surface tension is vary with the temperature. We can also use the platinum. If you have to consider the platinum, then we can be easily measure the surface tension of the molten metal of the can be determined. We can also variation of the surface tension of the solution. We can determine with the respect to the concentration of the solid. We can be study. Means we can be vary the concentrations of solid. We can be determine the corresponding surface. A fourth application is the surface tension of the different liquid can be determined and is compared. And last is the molecular aggregation of the liquid, which can be also studied. So these are the application. We should be remember it. Now what is the drawback of it? If there is an application advantage, there is also one part that is the drawback. What is the drawback actually? There is no absolutely certainly that radius of the bubble you have to detach from tube is the same as that of the radius of the aperture. Means there is no 100% sure that is the air bubble's radius exactly same as an air radius of the your capillary tube. Okay, so it may not be spherical. So for greater accuracy, you can be modify that above equation. So modify equation is like this. That is Rg H rho minus D. Now this H, that is the depth of the is R H plus twice R upon 3. R is an your radius of the capillary tube. So this is only one disadvantage or drawback of your the application of the Jaeger's method. Should be overlooked once again for the actually what is the Jaeger's method. You should be remember Jaeger's method is an actually it is a very simple that principle used here is an capillary action method, and here to suppose here you should be remember here that is your water is a filling. So here is a forced out, that here is a passed through the your capillary tube and it is and it comes here. So liquid which is already present here with capillary action is a forced in a downward direction. So here will come at the point B. So it is an hemispherical shape of that here bubble start. So at the maximum pressure is created. Then at the maximum value of the pressure it is detached. So at that you have to determine the manometer liquid height difference by using the traveling microscope. So you should be determine the high difference or by the naked eye if you have to observe. So you can be also measure the H depth and you have to determine that is the pressure inside the air, that is the pressure at this point and pressure at this point. We have to determine the excess pressure inside the air bubble. So excess pressure is that is here is the P1 is equal to P plus H rho G. Rho is the density of this liquid and should be remember here is we can use the D parameter for the density of this liquid. Okay, and rho parameter for the density for this liquid. Okay, so you should be remember these two parameters is determined for the density. Yeah? So you should be remember that is rho is always used for the density, but there is two liquids, so you can be vary your variable, so symbol, so it is a D. So in this way, can be determine the surface tension of the any liquid by using this method. Practically also you have to prove it. So we get the surface tension, and this is another advantage and application of the surface. So now there is only one article we will see in next lecture, or it will be the tomorrow. So this is about your the surface tension.